Hello, good day everyone. Welcome to the second part of our discussion on the preparation of plasma for coagulation studies. So the part one was all about the preparation of the sample when used for running PT and APTT tests. But for this one, the preparation that we are going to perform here is more on the preparation of the sample for the substitution or mixing studies. The first type of sample that we are going to prepare is what we call the adsorbed plasma. So this sample can be prepared by using either barium sulfate or aluminum hydroxide. Adsorbed plasma is deficient in the following factors. We have factors 2, 7, 9, and 10. And take note that these factors are also factors that belong under your prothrombin group or the vitamin K dependent group. Even if they are deficient in those factors, your adsorbed plasma also contains factors 1, 5, 8, 11, and 12. Now, here's the procedure on how to prepare your adsorbed plasma. If you're going to use the barium sulfate adsorption, you have to add 50 milligrams of your barium sulfate to 1 ml of your plasma and then incubate the sample at 37 degrees Celsius for 15 minutes with frequent mixing. After 15 minutes, you may centrifuge the sample at 2000 RPM to obtain a clear supernatant fluid. So that is how you prepare your adsorbed plasma using the barium sulfate adsorption. On the other hand, if you're going to prepare your adsorbed plasma using the aluminum hydroxide adsorption, you have to add 1 gram of your aluminum hydroxide to 4 ml of your distilled water to prepare your aluminum hydroxide suspension. After that, add 1 part of the suspension to 9 parts of your citrated plasma or the sample coming from your light blue top tube. Mix well and incubate for 5 minutes at 37 degrees Celsius. Centrifuge the sample at 2500 RPM to obtain a clear supernatant fluid. The next type of sample that will be used for mixing studies is what we call the age serum. So this age serum is deficient in factors 1, 2, 5, 8, and 13. However, it also contains factors 7, 9, 11, and 12. So here's a procedure on how to prepare your age serum. So you have to collect a non-anticoagulated specimen, and that specimen will be allowed to clot, and it must be incubated at 37 degrees Celsius for 3 hours. After incubation, you have to add 0.1 molar sodium citrate in the ratio of 1 part of your sodium citrate to 9 parts of whole blood to the specimen tube. Allow the tube to incubate at 37 degrees Celsius for an additional 2 hours. After incubation, centrifuge the specimen for 10 minutes and remove the serum. So before using your age serum, you have to dilute it with 0.85% sodium chloride using a ratio of 1 part of your serum to 4 parts of sodium chloride. So we have here a table of the coagulation factors in different preparations of plasma or serum. So in the first column, you can see there all of the clotting factors listed. And in the succeeding columns, you have there the different preparations of plasma and serum, like fresh plasma, age plasma, you have the adsorbed plasma, fresh serum, and age serum. So for the fresh plasma, of course, it contains all the clotting factors. In the age plasma, you have here factors 5 and 8 are absent because these are considered your labile factors. And then for the adsorbed plasma, factors belonging to your prothrombin group or the vitamin K dependent group are absent, like factors 2, 7, 9, and 10. And then you have for the fresh serum, it does not contain your factors belonging under the thrombin sensitive group, your factors 1, 5, 8, and 13. It does not also contain, or it only contains residual prothrombin of less than 20%. The age serum also does not contain the factors that belong under your thrombin sensitive group, your factors 1, 2, 5, 8, and 13. So we have here other preparations of our plasma or serum. So aside from the adsorbed plasma and age serum, we also have fresh plasma. And again, it contains all the clotting factors. Then you have your age plasma does not contain factors 5 and 8, which are considered labile factors. Your adsorbed plasma, it does not contain your vitamin K dependent factors, your 2, 7, 9, and 10, because they are adsorbed by either your barium sulfate or aluminum hydroxide. Your fresh serum, it does not contain your fibrinogen group coagulation factors, your 1, 5, 8, and 13, and it contains residual prothrombin, but it's only less than 20%. For age serum, like your fresh serum, it does not also contain the fibrinogen group coagulation factors and factor 2. Okay, now we discuss about substitution or mixing studies. So what is mixing studies, or why do we need to perform mixing studies? Mixing studies are tests that are performed on citrated plasma of our patient, and it is used to distinguish factor deficiencies from factor inhibitors. Factor inhibitors such as your lupus anticoagulant or specific factor inhibitors like antibodies directed against your factor 8. Mixing studies take advantage of the fact that factor levels that are 50% of normal should give a normal PT or APTT result. It can help determine the appropriate next steps to take to diagnose the cause of an abnormal APTT or PT. For the principle behind your substitution studies, when the PT or APTT or both of these tests are abnormal, further testing may be done to identify the specific abnormality because it may be due to a factor deficiency or a circulating inhibitor. The coagulation test with the abnormal result is repeated using several different dilutions of the patient's plasma and the normal plasma. The testing is performed immediately and after incubation at 37 degrees Celsius. So if the abnormal result is corrected by the addition of normal plasma, a factor deficiency is indicated. However, if in the addition of the normal plasma there is no correction of the abnormal result, it only indicates that there is the presence of a circulating inhibitor. So the patient's plasma is mixed in this ratio 1:1 with normal pooled plasma that contains 100% of the normal factor level, which results in a level of greater than or equal to 50% in the mixture. So, for example, if the citrated plasma of the patient does not contain any clotting factor, so it's typically deficient of the clotting factor, so the patient's plasma has an activity of 0%. If you're going to add fresh plasma, for example, of course, that contains all the clotting factors. So we have an idea that the um, fresh plasma activity is 100%. So if you're going to get the average of the activity of the patient's plasma, which is 0%, and you added 100%, of course, the result would be 50%, and this would be enough to give a normal PT or APTT result. Therefore, correction with mixing indicates factor deficiency, or failure to correct indicates an inhibitor. So we have a sample problem here wherein the patient has a normal PT result. However, the APTT result is prolonged, which means to say that there is a deficiency in the coagulation factors of the intrinsic pathway. So that is your factors 12, 11, 9, and 8. However, when the mixing study was performed, so you have here the addition of zero point 0.1 ml of the patient's plasma in APTT plus fresh plasma, the deficiency was corrected, and then um, upon addition of the normal adsorbed plasma, the deficiency was also corrected. However, when age serum was added to the patient sample, the deficiency was not corrected. So the question is, which coagulation factor is deficient? Is it A, factor 12? Is it B, factor 1? Is it C, factor 11? Or D, factor 8? For the solution on that problem, so we have here the possible coagulation factor deficiencies, which are factors 12, 11, 9, and 8, because the patient's results showed a prolonged APTT. Now, when adsorbed plasma was added to the patient sample, the factor deficiency was corrected. And these are the factors that are present in your adsorbed plasma. You have factors 1, 5, 8, 11, and 12. However, when H serum was added into the patient's plasma, the coagulation factor deficiency was not corrected. So these are the absent coagulation factors in your H serum. You have factors 1, 2, 5, 8, and 13. Therefore, the coagulation factor that is deficient, which caused the prolonged APTT result of the patient, is factor 8. Notice that your factor 8 is found in your adsorbed plasma, but it is not found in your H serum. So, a technique for solving these types of problems, especially in your substitution studies, all you have to do is, um, if for example the patient's coagulation factor deficiency was corrected by plasma or H serum, when it says corrected, you have to list all the factors that are present in that preparation. Let's say for example, in adsorbed plasma, you have factors 1, 5, 8, 11, and 12. However, if the clotting factor deficiency was not corrected, all you have to do is list the factors that are absent in the preparation. So for example, in the H serum, it says there that um, the clotting factor deficiency was not corrected. So you have to list all the possible clotting factors that are absent or not present in your H serum, and these are your factors 1, 2, 5, 8, and 13. Now, when you try to compare these factors in your adsorbed plasma and H serum, try to look for the factors that are present in both preparations. So, if you take a look at your adsorbed plasma, it has factor 1, right? And also in your H serum, it also has factor 1. So you can actually encircle these factors, denoting that these factors exist in both your adsorbed plasma and H serum. So you have factor 1. Aside from factor 1, you also have factor 5. Factor 5 is present in your adsorbed plasma, and you can also see factor 5 listed in your H serum. So you have to pair this one also. Aside from factor 5, you also have factor 8, and you have, yeah, I think that's it. Factors 1, 5, and 8. Now, try to assess the factors that are paired. So you have factors 1, 5, and 8. Now, we know that um, the problem here is a prolonged APTT result, which means to say that the problem lies, or the deficiency lies, in the intrinsic coagulation pathway. And remember that your intrinsic coagulation pathway, it is concerned with four factors, your factors 12, 11, 9, and 8. Now try to look at the factors that were paired in your adsorbed plasma and H serum. If you try to assess factor 1 does not belong in your intrinsic coagulation pathway. It belongs in your common coagulation cascade or pathway. Factor 5 also, it does not belong to the intrinsic coagulation pathway. It also belongs to the common coagulation cascade. Factor 8 is the only factor which has a pair that belongs to your intrinsic coagulation cascade. So, probably the reason why the APTT result of the patient is prolonged because he or she lacks factor 8 in her coagulation cascade. Okay, another sample problem that we have here is we have the patient's result. The patient's PT and APTT results are both prolonged. Okay, remember that your PT, it's a screening test for the factors in your extrinsic coagulation pathway. Your APTT, on the other hand, it's for the intrinsic coagulation pathway. But since both of these tests are prolonged, the problem is not in the extrinsic or the intrinsic coagulation pathway, but it is in the common cascade. Okay, so you have here, um, in the substitution studies, no, you have here 0.1 ml of the patient sample, situated sample, plus fresh plasma. The clotting factor deficiency was corrected, and then when normal adsorbed plasma was also added, the deficiency was also corrected. However, when age serum was added, the deficiency was not corrected. So the question is, which coagulation factor is deficient? Is it A, factor 2? Is it B, factor 1, or C, factor 5, D, factor 8, or letter E, 2 of these? So let's try to look at the solution. Okay, so for the solution, we have here the possible coagulation factor deficiencies, and these are your factors 10, 5, 2, and 1. Take note that the problem is that both of the PT and APTT results are prolonged, so it's not in the intrinsic or extrinsic pathway which has the clotting factor deficiency, but it is in the common coagulation cascade. Now, upon addition of the adsorbed plasma into the patient's sample, the deficiency was corrected. So since the deficiency was corrected, we have to list all the factors that are present in your adsorbed plasma, and these are your factors 1, 5, 8, 11, and 12. Next, when age serum was added to the patient's plasma, the coagulation factor deficiency was not corrected. So we have to list all the possible coagulation factors that are absent in your age serum. And these are your factors 1, 2, 5, 8, and 13. Now, using the technique that I have taught you earlier, what you're going to do is you have to pair the factors that are listed in both your adsorbed plasma and age serum. So you have here for adsorbed plasma, you have factor 1, and in your age serum, you also have factor 1. So you have to pair these two. And then you also have factor 5. So factor 5 is present in your adsorbed plasma, and you can also see factor 5 listed in your age serum. So you also have to encircle this pair. Next, we have factor 8. Factor 8 is also seen in your adsorbed plasma, and factor 8 is also listed in your age serum. So you have to encircle that one. And then, yeah, I think that's it because factors 11 and 12, we cannot see factors 11 and 12 listed in your age serum. So these are the three pairs of factors that has the possibility to cause the deficiency in the common coagulation cascade, resulting to prolonged PT and APTT results. So let's try to assess each one of them. So remember that our target here is to determine which factor caused the deficiency and which factor belongs to the common coagulation cascade. So you have your factor 1. So factor 1, of course, it's listed here for the possible coagulation factor deficiency. So this factor um, may have caused the prolonged PT or APTT results. Okay. Factor 5, on the other hand, is also another possible clotting factor that have caused the prolonged PT-APTT results of the patient. So that could be um, part of our list of factors that cause the deficiency. However, factor 8, it's not part of the common coagulation pathway. Factor 8, it's part of the intrinsic coagulation cascade. So our conclusion for that problem is this one. The coagulation factor deficiencies are your factors 1 and 5. And these two factors are part of your common coagulation pathway. Another thing, your factors 1 and 5, they are both found in adsorbed plasma but not in age serum. Okay, so the answer for that problem is factors 1 and 5. So that's it for our discussion on the preparation of plasma for the mixing or substitution studies and how to determine the factors that cause the prolonged PT and APTT results of our patient, or how to determine the deficient coagulation factor. So I hope you were able to learn something from this discussion. And if you have any questions, please do not hesitate to ask your teacher or your laboratory preceptor. So thank you so much, guys, for listening, and have a good day.